Good. All right. We are very excited about today's presentation because we're actually doing an announcement. So today we will be giving you some details about a project that we've been working on over the past few months at Canonical. And before we go into the details of this announcement, it helps to paint a picture of the vision that we're going for. We want to explain the future we want to build. So we see Ubuntu as becoming the standard aggregation platform for AI models. We see AI models becoming a standard part of the compute experience, native to the compute. I can already hear some of you thinking, but wait a second, isn't that already the case? Don't we already all use AI models multiple times per day? Aren't AI models and LLMs already everywhere? That is correct, but the vision that we're going for is much more ambitious than that. In order to explain it, let me help by giving you an analogy. If you think about the early days of software development, starting in the early 90s, for instance, in order to get access to new software, you had to go look for it in a CD from your friend or from a floppy disk. That experience was very cumbersome, was very fragmented. Over the course of decades, that experience improved. It became much more smooth, much more streamlined. Thanks, for instance, to the likes of Slackware, the likes of Debian. They started by creating curated archives of software. But it was still quite a fragmented experience. You still had to go look for the specific repositories in order to get access to a certain package for your problem. We believe that by standing on the shoulders of these giants, with Ubuntu, we also helped improve that experience. So that today, Ubuntu is the de facto conduit of open source software. And think about how much has changed over the past few decades, from having to scout for the latest package and the latest repository, to simply treating packages and dependencies as a commodity as an application developer. Today, when you do development on Ubuntu, you don't have to worry about which repository is behind your package. You don't have to worry about pulling software from a certain OS vendor. You can just rely on the package system of Canonical and on the release cadence that we provide. What if we could do the same with AI models? The problem is that with AI models today, the problem is that it's very fragmented ecosystem. Instead, we want to treat AI models just like a commodity for application developers. The issue is that AI models today are everywhere, as I was mentioning. You have different models coming from different model vendors. For instance, in this example, you have Mistral AI, which is the vendor, providing a variety of models. They come with different shapes and sizes, with different size of parameters. And these are the base models that developers need to use for different use cases. If then you want a very tailored application, if you have a specific use case in mind, often you use an optimized model, what is called a fine-tuned model. In this example, you have the instruct model, which is fine-tuned, with 7 billion parameters. So already developers need to know, among this proliferation of models, which ones to pick for their specific use case. And this is just from one vendor. Of course, we are all aware of the proliferation of model vendors out there. And that is not enough, because a model on its own, at the end of the day, is just a collection of weights. You have billions of parameters that have been trained, but that is not enough to perform inference. To do inference, you need an inference engine. And what's the issue? The issue is that there are multiple inference engines per model because they support different hardware features. LLM providers, silicon vendors themselves, they create different inference engines that work on different silicons. So now you have a matrix of complexity. You want to take advantage of the AI models, but as a developer, first of all, you need to pick the right model, whether it's a base model or a fine-tuned model. And then you need to match it to the right inference engine on your specific silicon in order to take advantage of the optimizations done at your hardware level. And it doesn't end here, because the silicon vendors themselves provide silicon-optimized versions of the AI models. So what you end up in practice is developer leaving their hardware underutilized because they're not correctly picking the right inference engine. They're not using the right optimizations, which come in many forms, including quantization. And you have developers in this fragmented, cumbersome ecosystem, similar to the early days of software development. What if we could improve that experience? What if instead developers in a single click could simply get access to the right combination of model, inference engine, optimized for their hardware? What if they treat AI models just like a commodity as any other standard software artifact is on Ubuntu today? To give you more details, these are some of the examples of the inference engines that are available to this specific fine-tuned model by Mistral with 7 billion parameters. What if you could simplify that experience for developers and treat an AI model as a simple part of the compute experience that they can just access to start the development? Farshid.
Thank you. We work closely with various silicon vendors and try to make sure the best hardware that they create becomes available on Ubuntu to various users and developers. In practice, developers of embedded AI applications still have to deal with API keys, cloud subscriptions, and a lot of complexity, internet access. The reason for that is because it's very difficult to package and distribute and manage generative AI applications. Developers need to worry about tens of different silicon. They need to worry about various different combinations of the hardware. And even if they figure that out, they also need to deal with updates and newer generations of the hardware that come along. With inference snaps, we believe we have a solution that can tackle this problem. This solution is built around the Snap ecosystem, providing existing functionalities that have been developed over the decades for packaging, distribution, dependency management. And why not treat AI models the same way as typical software artifacts? We are trying to make it easier for hardware vendors to make their newest and best hardware available to developers that are trying to access and give their users the best experience. We have created an architecture, and we are open sourcing that architecture and the tooling today to make it possible for people to create generative AI snaps. We call them inference snaps. This architecture allows bundling various different combinations of runtimes and weights into a single snap, but deploy only what is needed and most optimal for the host machine. Let's jump into a demo, if it loads. This is OpenWebUI. This is my favorite client for dealing with LLMs. It's very feature complete. It gives me access to various endpoints that I have configured. Now, in practice, in many cases, this is not what I would need. I would need access to private and local APIs to deal with confidential and internal resources. I can quickly jump to a terminal and install an inference snap, in this case, QNVL. When I install it, it detects my hardware and it installs the right bits that are most optimized for my hardware. So as a user, I would get the best performance for my hardware, the performance that has been decided by the silicon vendors. You saw that OpenVINO was being installed because I have an Intel machine, and now you see that a model that has been compiled and optimized for my machine is being installed. If you do the same thing on another machine, it's going to give you something different. Now, this is fast forward. In practice, it takes a few more minutes to complete. But as soon as it's done, I can just grab a standard endpoint for this application, in this case, OpenAI. I can go and configure my client by easily pasting that URL. And as simple as that, I just install the snap, and my client is just ready to use that. Now I can access Qwen from this client directly. And then this opens, different possibilities. I can save HR resources instead of, keeping them busy with trivial questions. I can just upload the policy and ask questions about it. The model, ideally, has the best performance available. So when I make queries, this makes the best use of my hardware. I can also hold a conversation. So this client actually suggests very good questions depending on the context. But I'm free to hold a rich conversation. And only if things don't work out, I go to the HR and ask questions from them directly. Or maybe I'm working on the next cool project that's still internal. I have a very difficult bug, an error in the terminal. I can just attach it. And then I can ask the AI for explanations on that. And this would give me an elaborate answer on that problem and possible ways of solving it. If I go back to the terminal, I can see that Intel GPU engine was automatically selected. This engine gives the best performance on my GPU. I can see that there were a bunch of other engines available. Not everything is compatible, but one was automatically selected. I can switch to something else and experiment. This slide wasn't updated, but the press release is available now. And please take a look. Please Google it. You will find it. And give us feedback. This is a beta testing. We want your feedback. We want to know whether this platform is the best for developers. We want to know whether this satisfies the requirements that you have. And we want to hear about everything. If you find bugs, file it. Thank you.